call is now being recorded.
Okay, so related to the industrial engineering, you are having the assignments as well as practicals also. So in the form of assignments, we are conducting the different types of the MCQ test. So different types of the MCQ test we are conducting. So up to this, today also we have solved, or I have given one test related to the MCQ test number 3 based on the chapter number 3. I hope everyone has attended that. So now in the today's lecture, we will cover the two practicals related to the industrial engineering. But before starting that particular practicals, just we will take the overview, which experiments we have to perform in this particular subject. That is, here in front of you, I have represented the list of the experiments. So total you have to perform total 7 experiments are there for your syllabus. The experiments are based on the different types of the chapters, whatever we are covering in this particular subject. So whatever first chapter we have discussed related to the introduction to the industrial engineering and the productivity. Based on that first chapter, you are having the 2 experiments. That is the name of the first experiment is that the role of industrial engineer in the industry. So this is your experiment number 1. So what is the role of the industrial engineer? Similar to the production engineer, similar to the design engineer, similar to the R&D engineer, then inspection department is there. For the respective departments, the different types of the engineers are to be provided. In addition to that, here, as the role of the industrial engineer is very important in order to improve the productivity of that particular organization. Therefore, the role of the industrial engineer, it also plays very important role. Therefore, in many of the big scale industries, in short scale industries, such types of the engineers are not there. But whatever the big scale industries are there, where the maximum production is taking place, or in such type of the industries, the industrial engineers are also appointed. So what is the role of that particular industrial engineer? So in the chapter number 1, whatever we have discussed related to the basic introduction to the industrial engineering, whatever the different types of the concepts we are implementing, maybe we are implementing the concept of method study, how to increase the productivity, then we are implementing the concept of all the ergonomic concept, all the different types of the industrial safety, then current chapter, whatever it is going on related to the work measurement, whatever the number of activities we are performing, whatever we have discussed in the last 3 chapters, that all the activities are performed under the guidance of the industrial engineer. Therefore, the role of the industrial engineer in the industry, this is your experiment number 1. Okay, then experiment number 2, case study on the productivity. So as we know that in the chapter number 1, we have solved 2-3 problems based on the productivity calculation. So what is meant by the productivity? If you go through the simple formula of the productivity, that is productivity is equal to total output upon total input. Okay, so this is the simple formula, total output upon total input. The inputs are available in the different types of the parameters. Maybe inputs are in the form of labor input is there, then capital input is there, then raw material input is there, then some another energy input is there. So many input parameters are there, but if we give all those particular inputs, you will get only one output in the form of finished products. If you have to convert your raw material into the finished goods by using the machines or by using the operators, it is not possible to convert your raw material into the finished products. So for that particular conversion, number of inputs we have to utilize in the form of the labors are required, then machines are required, some equipments are required, then capital investment is required, some additional energy is required, and some other miscellaneous are required. That means so many inputs are there, but by implementing that so many inputs, you will get one output in the form of your total, you will get the output in the form of your final products. So the second experiment is based on the case study on the productivity, that is how to calculate that particular productivity. So we have discussed about the 3 types of the productivity. That is, first one is called as a total productivity, which is equal to total output upon total input. This is the simple formula. Then partial productivity. What is meant by the partial productivity? The partial productivity is calculated for the respective input parameters. For example, you are giving the so many inputs. Maybe labor input is there, capital input is there, material input is there. There are so many inputs are there, and there is only one output. But from that particular total output, how much percentage share is given by the labor? How much percentage share is shared by that particular material? how much percentage share is shared by that particular capital investment. That means for each and every input, whatever the productivity we are calculating, that is partial productivity is equal to total output upon labor input, not total input. Then partial productivity is equal to total output upon capital input. Then second, total partial productivity is equal to total output upon machine input. That means for each and every input parameters, if I am calculating for each and every input parameter, if I am calculating the productivity, then that productivity is called as a partial productivity. And the third one we have discussed about the total factor productivity. So this is also one of the type of productivity in which you are having the formula TFP. In short, it is called as a TFP. That means total factor productivity is equal to net output upon labor plus capital input. In case of a total factor productivity, out of number of inputs, we are taking only two inputs for your further calculation, which are called as a labor and the capital productivity. So in this particular case number, in experiment number 2, we are going to solve one problem. That is how to calculate the productivity for any type of industry. Then third experiment is called as number 2. We have discussed in detail. Method study means to eliminate the unnecessary operations in order to increase the productivity. So whatever the number of operations we are performing, while performing that particular operation, some unnecessary operations are generated. So we have to eliminate that unnecessary operations, and that we have discussed in the chapter number 2 as a method study, in which we have discussed different types of the charts. Maybe operation process chart is there, two-handed process chart is there, flow process chart is there, multiple activity chart is there, then different types of the diagrams in the form of string diagram is there, flow diagram is there, different charts, templates, like that. So many different types of the parameters we have discussed under the concept of method study, through which you can eliminate the unnecessary operations. Then your experiment number 4, that is time study. So whatever the current chapter is going on in our class, which is called as a work measurement. The concept of work measurement is also called as a time study, where we are calculating or we are measuring the time required to perform the operation. How much amount of time is required to perform your drilling operation, fishing operation, whatever the number of operations we are performing. Also, how much amount of time is required to operator to travel the distance from one machine to the another machine. Like that, all the required time, whatever it is required, that is calculated by this particular time study concept. That is, we are going to study experiment number 4 related to the work measurement. Then experiment number 5, which is called as a pinboard study experiment. So pinboard study experiment is also based on the experiment number 4, that is time study. What is the experiment number 5 is there? It is totally based on the experiment number 4, because pinboard is one of the study type of experiment. Pinboard is one of the study type of experiment in which actually we are performing that particular experiment that is related to the time required to perform your job. Time required to perform your job. Because what happens, sometimes whenever we are working on any type of machine, if we are working on that particular machine and at that time we are using only one hand for your operation, maybe I am using only right hand for the operation. But if I am using only right hand for completing this particular task, maybe maximum time is required to complete that particular work. But if I will utilize my both hands to complete that particular task, that means some of the activities I can perform by using the left hand and some of the activities I can perform by using the right hand. That means to complete the same work, if I am using the both hands, at that time the time required to complete that particular task is very less. Therefore, utilization or complete the work by using the single hand and complete the same work by using the both hands, that concept is called as a pinboard study experiments. That means if you are performing your work by using the single hand, how much amount of time is required, and if you are performing same work by using the two hands, how much less time is required as compared to the first experiment. So that comparison we are going to make in this particular experiment number 5. Then experiment number 6, that is case study on the plant layout. So this is related to your chapter number 5. Currently the chapter number 4 we are discussing in our class. Chapter number 5 is related to the facility location and the plant layout. So here the experiment number 6 is also based on the case study on the plant layout. That is, there are different types of the layouts are there. Product based layout is there, fixed position layouts are there. Based on that, we are going to discuss about this particular experiment number 6. And last experiment is called as a job evaluation and the merit rating. So this is the experiment number 7. Again, it is the study type experiment in which we are going to discuss the two important concepts related to the job evaluation and the merit rating. Whenever your final product is prepared, when it is finalized, we have to go for the evaluation, because similar type of the jobs are there in your industry. At that time, we have to go for its evaluation. We have to go to checking its performance, whether your finished product is working in good manner or not, whether he is applicable for the further application or not. Like that, so many tests are conducted under the job evaluation concept. And next is called as a merit rating. So merit rating is the concept related to the, you have to give the rating to your product, as well as you have to give the rating to the performance of the operator. So many products are manufacturing. Out of that, which product is best one, which give the good performance? Accordingly, the rating will be given to that particular product. In addition to that, whatever the number of operators are working, some of the operators are doing their job very sincerely. So in such cases, we have to provide the ratings to that particular operators according to his performance. So based on this particular 6 chapters, whatever it is there in our syllabus, based on that only, here we are having the total 7 experiments in our syllabus. But based on the chapter number 1, 2 experiments are there, and the remaining 4 experiments are based on the remaining 5 chapters. So up till now in your class, we have started the chapter number 4 based on the work measurement. That means up to the experiment number 4. Now we can easily understand all the concepts, but experiment number 5, 6, 7, we will discuss afterwards when we are covering their respective chapters. But now for the today's lecture, we will cover the experiment number 1 and experiment number 2, because both the experiments are based on the chapter number 1 only. The experiment number 1 is very simple. It is related to the role of industrial engineer, and the second is related to the productivity, in which we will solve one sample problem. Then we will cover experiment number 1 and 2. Okay, so now the assignment number 1 or the experiment number 1, that is the role of industrial engineer in the industry. So what is the role of that particular industrial engineer? So I have explained the things. So whenever we are working with any big scale industries where your maximum production is to be taking place, at that time, in addition to the production engineer, design engineer, quality engineer, inspection engineer, same then another some transport related engineers are there. Here the role of industrial engineer, it also plays very, very important role, because whatever up till now, whatever the 3 chapters we have discussed related to the method study and the work measurement. So what is meant by the method study? As I have discussed, that is, you have to eliminate all the unnecessary operations. Whenever we are converting your raw material into the finished goods, so many operations we are performing, starting from the piecing, then turning, then some gluing operation there is, threading operation is there, shaping operation is there, champering operation is there, drilling operation is there. Like that, so many operations we are performing to convert your raw material into the finished goods. But while performing such number of operations on that particular job, unnecessarily, some unnecessary operations are also obtained. So if I have to eliminate that particular unnecessary operations, I have to implement the concept of method study. Implementation of concept of method study in the industry means we have to provide the industrial engineer. Production engineer will not focus on that particular elimination of unnecessary operations. Then another quality engineer is also not focused to eliminate that particular unnecessary operations. So in order to track such types of the activities, the industrial engineer, it plays very, very important role. Therefore, whenever we have to go for the elimination of unnecessary operations, whenever we have to go for the measurement of time for each and every operation, whenever we have to consider all the ergonomic concepts, means whatever the workstation we are designing, whatever the machines we are designing, whether that machine is properly feasible to that particular worker or not, because sometimes the height of machine is very high, okay, and the height of the person is very less. At that time or in such conditions, it is not possible to operate that particular machine by that particular operator. Okay, sometimes whatever the sitting arrangement is provided, whatever the table is provided, that will be not in that particular table or in that particular chair, the operator is not comfortable. At that time, we have to consider ergonomics concept in that particular industry. If I will apply all those particular ergonomic concepts in the industry, then that workstation, that machine, that sitting chair, that table, it will be comfortable to that particular operator. Then who is concentrating on this particular activities? Implementation of method study concept in the industry, implementation of work measurement in the industry, then implementation of all the ergonomic concept in the industry. Who is implementing all this particular concept? That is industrial engineer. He is implementing all those particular concepts in the industry. Therefore, he is implementing all the concepts in the industry. Therefore, whenever we are working or the operators are working on any workstation, so he will be satisfied with all that particular workstation. So, therefore, the role of industrial engineer, it plays very important role. So, in addition to that, here some function of the industrial engineers are also there. That is, first function is to develop simplest work method and establish the best way for doing the work. To develop the simplest work method means whatever the number of methods we are having, that means one product we can manufacture by using the different types of the methods. But out of that particular number of methods, we have to select the best method and the simple method. Through that particular method, we can complete your job in less time and the less cost. So at that time, the industrial engineer, it plays very important role. Then second, setting the performance of standards to evaluate the performance of worker. Setting the performance of standards. Some of the operators are there are fully skilled operators. They are operating CNC machine, VMC machine. Some unskilled operators are there. Maybe some unskilled operators we are using for transporting the products from one location to the another location. So for the simple activity, we are giving the unskilled operators. But in order to operate some sensitive machines or some big machines or the CNC, VMC machines, at that time we have to provide the skilled operators. So where the skilled operators we are providing, at that time we have to evaluate their performance, whether that skilled operator is performing his task or her task in the effective manner or not, whether he or she completing his work within given period of time or not, how he is performing his work, whether he is completing his task within time or not. So like that, we have to check the performance of that particular worker. Therefore, who is checking the performance of that particular worker? That is industrial engineer. So therefore, the role of industrial engineer is also important in order to check the performance of the worker. Then to develop sound and fair wages and the incentive scheme. Incentive schemes, then fair wages, sounds means if you are doing your overtiming work, if the workers are doing their works in the effective manner, at the time additional wages, additional incentives, or in the form of promotions. Such types of the schemes should be provided in that particular industry. Then who is looking to such type of the activities? That is industrial engineer. So once the industrial engineer will check the performance of that particular operator, if your performance is acceptable, then he can give some extra wages to him, he can give some additional salary to him, or also he will give the promotion to the such types of the workers. Then fourth one, it helps in developing and designing the inventory control of the system. As we know that the inventory control plays very important role in the industry. Therefore, for developing and the designing of the inventory, so the role of industrial engineering is also very important. It helps for the preparation of job description and the specification. So whatever your final product is ready, final job is ready, to that particular job, we have to give the description. So what is the output of that particular job, where this particular job is applicable, what is the performance of that particular job, whether that job is working in the good manner or not. So like that, we have to give the detailed information in the form of job description and the job specification, whatever the important specifications are there. What is the weight of that particular job, where it is to be applicable, what are the vertical dimension, horizontal dimensions, what is if your rotating job is there, then at how much speed it is to be rotating. So like that, all the detailed specifications, it is also given by that particular industrial engineer. Then development of cost reduction and the cost control system. This is very important. So whatever the work we are performing, that work can be completed in less time and the less cost. If machine is operated by the unskilled operator, at that time there is a possibility to increase the production time and there is an increase in the production cost. Therefore, wherever it is required, we have to provide only skilled operators, so your production cost can be reduced along with your production time. If your production cost is less, production time is less, automatically the efficiency and the productivity of that particular organization goes on increasing. And last one, to help in the selection of plant layout of machines to allow the smooth flow of the material. So whatever the plant layouts we are designing, whenever we are starting with the new industry, at that time, whenever we are designing the layout of our industry, at that time, this industrial engineer plays very, very important role. At one side, your inputs are there, and at the another side, your output is there. So at that time, we have to prepare the proper flow. In which sequence the machines are to be located, in which sequence your material will be flow from one machine to the another machine, from second to third to fourth, like that you will get the output. So at that time, while designing the plant layout, while selection the plant layout, while designing the flow of the machines and the flow of the raw material, at that time the role of the industrial engineer is also plays very, very important role. That means before starting the industry and once the industry is started, in both the conditions, in both the activities, the role of the industrial engineer plays very, very important role. So this is your experiment number 1, which is very, very simple. It is totally study type of experiment, that is role of industrial engineer in the industry. So in our class, whatever the chapter number 3 chapters we have covered, that is all the 3 chapters. In that, whatever the different types of the concepts are there that we are implementing in the industry, during that particular implementation, this industrial engineer, it plays very, very important role. So without industrial engineer, it is not possible to apply all those particular concepts, and it is not possible to maintain it. Sometimes we are applying all the concepts, but it is not possible to maintain. So in order to maintain that particular activities at the constant rate, the industrial engineer plays very, very important role. So this is a very simple experiment, that is study type of experiment is there, that is experiment number 1 or the assignment number 1. And based on the chapter number 1 only, you are having the second assignment, that is experiment number 2, that is case study on the productivity. So whenever I have to check the efficiency of the industry, whenever I have to check the output of that particular industry, at that time I am checking the productivity of that particular industry. If I have to check the efficiency of the industry, efficiency it will be checked by using the productivity. I am checking the productivity means how much output is there, and in order to obtain that particular output, how much input parameters are there. Therefore, in each and every type of industry, this productivity will be calculated. So we are having the simple formula for the productivity. Productivity is equal to total output upon total input. And already I have given total output means there is only one output in the form of finished product and the finished goods. But in order to obtain that particular finished products, you are having the so many input parameters are there. So inputs are available in the form of labor input, capital input, raw material input, machine and equipment input, then some another energy sources we are using. This is also one input parameters, and rather than this, some other input parameters are there. If I will apply this number of inputs, then and then only you will get the output. And if your output is increases in less input parameters, if your output is increases in less input parameters, then we can say that the productivity is increases, because your productivity is directly proportional to the output. If output is increases, productivity is increases. But in order to increase that particular productivity, your input parameter should be less. Sometimes what happens, we are increasing the output, no problem. We are increasing the output, but in order to increase that particular output parameters, the input resources are also we are increasing. At that time, we cannot say that the productivity is increased. So we can say that the output will be increased. Productivity will be increased when output is increased, but it is in less input. Therefore, maximum focus we have to give in the industry, that is in minimum number of input parameters. If you will achieve the maximum output, then we can say that the productivity is increased. Okay, so this is about the basic definition of the productivity. Suppose I will give the example. What are the products we are manufacturing? whatever the products we are manufacturing, the cost of that particular product is 1000 rupees. Okay, this is the output. And in order to manufacture that particular product, near about 500 rupees are required. And in that particular 500, all the input parameters are considered. Maybe labor, just example I am giving, maybe labor is there, material is there, there's some another resources are there. That means out of 1000, 500 are required for the input parameters and remaining 500 is your output, is your benefit. In that case, I can say that your productivity increases. But in order to increase that particular output, the input parameters are required near about rupees of 900. That means there is only 100 rupees are there in your benefit. So at that time, we cannot say that your productivity is increased. Your output is increased, but the productivity is not increased. Therefore, in the less number of input parameters, you have to increase the output. Then we can say that your productivity can be increased. So this is the basic definitions related to the productivity. And as per the Industrial International Labour Organization, we have discussed the different types of the definitions. That is, as per the ILO, as we know that the long form of ILO, International Labour Organization, defines the total productivity is equal to ratio of aggregate output upon aggregate input. Aggregate output means total output upon total input. The partial productivity is the ratio of aggregate output upon single input. I have given the example. So many input parameters are there: capital investment, labor input, material input, raw material input, energy input. So many input parameters are there. And if I have to calculate the partial productivity, so partial productivity is equal to total output upon single input. Means, for example, partial productivity for the labor or labor partial productivity is equal to total output upon only labor input. Then second input, material partial productivity is equal to total output upon only material input. That means for the number of input parameters, if I am calculating the productivity, that type of the productivity is called as a partial productivity. So basically in the industry, there are mostly two types of productivities we are calculating. The first one is a total productivity and the second one is called as a partial productivity. So these are the two important definitions through which we can solve the different types of the numericals in order to check the productivity of that particular organization. Now here, the objective of this particular study here, the two objectives are there, that is to identify the parameters to measure the change in productivity of sale of Maharashtra company. So there is one company is there, that is sale. The Maharashtra company is there, that is one organization is there, and we have to check the productivity of that particular organization. And second objective is that to analyze the change in trends in the productivity from 2008 to 2012. So in the 2008, some input parameters are there. In 2008, some outputs are there. Then from 2008 to 9, 9 to 10, 10 to 11, and 11 to 12. So like that, the inputs are also increases, the outputs are also increases, but here we have to check that whether your productivity increases or not. So here in this particular experiment, what industry we have considered, we are having some readings from 2008 to 2012 for that particular respective industry, and whatever the inputs are there to that particular industry, according to their inputs and according to their outputs, we have to check that whether the productivity increases or not. Okay, so this is the case study is given in the experiment number 2. So here we are having the definition. Just now we have discussed that total productivity is equal to mandatory value of production divided by total input, that is total output upon total input in simple definition. And partial productivity is equal to total output upon particular input required. Particular input means material input is there, labor input is there, energy input is there, raw material input is there, other inputs are there. So all that particular inputs are considered under the particular inputs. So like that, in this particular case study, we have to calculate the total productivity as well as we have to calculate the partial productivity according to the inputs given. Okay. So this is related to the another important definitions are there. The total productivity of that particular steel industry, that is one industry is given. Then total output we have to measure. Inputs, which are inputs are given, that is number of inputs are there. You can see here one labor input is there, which is indicated by capital L. capital input is there, which is indicated by the capital C. Then material input is there, which is indicated by the capital R. And the miscellaneous input, maybe sometimes we are using the another type of energy, sometimes we are using the another types of the material, sometimes we are using the another types of the equipment. So all other parts we are considering under the miscellaneous inputs. So there are so many inputs are there. There are about labor input is the 1, capital is the 2, material is the 3, miscellaneous is the 4. So these are the number of input parameters, and this is the data in front of you I have represented. So this is the one company, that is Steel Authorization of India Private Limited, the Steel Authority of India Private Limited. So what is the table I have represented in front of you? So the first column represents the years, 2008 to 2009, 2009 to 10, 10 to 11, 11 to 12. And in 2008 to 9, there are so many inputs are there. One is labor, then capital, then raw material input is there, and the miscellaneous inputs are there. So in 2008 to 9, how much input is there? It is represented in this particular table. Then in 2008 to 9, how much capital investment is there? It is represented in the third column. Then in 2008-9, how much raw material input is there? It is represented in the fourth column. Then for the 2008 to 9, how much miscellaneous inputs are there? It is represented by the fourth column. And the sixth column represents the total inputs for the 2008 to 9. That means here I have made the addition of labor input plus capital input plus raw material plus miscellaneous input is equal to total input. So this is the column. So sorry, this is the row which is applicable for the 2008-9, and the last column represents the total output in the 2008 and 9. Similarly, second row represents the year of 2009 to 10. Again, labor plus capital plus raw material plus miscellaneous inputs. So here the total input is also represented by this particular sixth column. And in 2009 to 10, what is the total output? Similarly, for the next year, 2010 to 11, again, these four input parameters are there. Their addition is also represented here, that is total input. And for this year, total output is there. Then for the next year, 2011 to 12, again, these are the four input parameters. Their addition I have made here, that is total input is there. And then at the last column, there is the total output. That means from 2008 to 9 up to the 2011 to 12, input parameters are same. Input parameters are same, and their total input is continuously increases. You can see in 2008 to 9, input is 29,918. In 2009 to 10, 38,497.25. In 2010 to 11, it is decreases 30,208. And last for the academic year, 39,180. So like that, for 2008-9 input is there, 10 for 2009 to 10 input is increased, then for 10 to 11 input is decreased, and then for 11 to 12 again it is to be increased. And at the last column, the output is also represented. That means for each and every academic year, the inputs are given as well as their outputs are also given. So this is one data analysis. This is one chart which is represented in front of you in order to calculate the productivity. And now what we have to calculate? So this is the table number 1 where all the inputs and outputs are given. Now in the table number 2, that is we have to calculate percentage share of different inputs in total inputs. Out of this particular total input, I'm saying about the total input. Out of this particular total input, how much percentage share is given by the labor? How much percentage share is given by the capital? How much percentage share is given by the raw material? And how much percentage share is given by the miscellaneous? So in the second table, we have to fill all this particular information. That is, if I have to calculate the percentage of the labor in 2008-9. So what I am using the formula, that is percentage share of the labor in 2008-9 is equal to total input divided by labor input. Total input divided by labor input. For example, let us see. Okay, so this is the table I have taken. Okay, so here the 2018-19 is there. Okay, so to this particular 2018-19, this is the total input. Okay, so if I have to calculate percentage share of labor, this is for 2008 to 9. Percentage share for the 2008 to 9, percentage share of labor is equal to total input divided by, out of this particular total input, how much percentage share is given by the labor? So that is labor input. So total input is equal to 29918.9 divided by 10437.02. So if I will go for the calculation of this particular part, you will get the answer, that is in the form of, so what will be the answer for this? That is 29918.9 divided by labor input 10437.02. So 2.86. So whatever the answer you will get, that is 2.86. So this is the percentage share of that particular labor input. Similarly, if I have to calculate the capital, that is percentage share of capital. Again, total input divided by capital input. So again, total output will be same, 29918.9 divided by 10.437.02. So again, I am doing the calculation, you will get the another type of percentage. Similarly, third, percentage share for the raw material. Again, I am having the formula, that is 29918 divided by, what is the labor input? 17257. Again, I am calculating for the miscellaneous, again total input upon miscellaneous input. So like that, I can calculate the percentage share of that particular respective inputs. If I am calculating the percentage share for the 2008-9, similarly for 2009 to 10, again I am calculating percentage share of the each input. So for 2009 and 10, I am having the total input near about, you can see 38,497.25. So this data, this total input divided by labor input means you will get the percentage share. Again, total input divided by capital input, again you will get the percentage share for the capital. Again, total input divided by raw materials, again you will get the percentage share. Similarly for the miscellaneous. Then for the next academic year, for 2010 to 11, you are having the total input 30,208.64. Again, for 2010 and 11, total input divided by labor input. Again, total input divided by capital, total input divided by raw material, and for miscellaneous. Similarly, for 2011 to 12, total input is given 39,180.37. Again, total input divided by labor, then capital, then raw material, and then the miscellaneous. So like that, we have to follow same procedure. We have to follow same procedure in order to calculate the percentage share of the each and every input. So once again, percentage share of each and every input, that is, if I will calculate percentage share of each input is equal to total input divided by required required input. So this total input will be same, but required input, it consists of a material. Then it consists of a labor. Then it consists of a capital. Then it consists of a author. So that is so many, whatever the number of inputs are given, that inputs means your required inputs. If I will divide to this particular total input by the required input, I will get the percentage share of this particular each material. म्हणजे total input percent मधून किंवा total input मधून प्रत्येक इनपुटनं किती पर्सेंट डाटा शेअर केला किंवा किती पर्सेंट मटेरियल शेअर केलं किंवा त्या प्रत्येक इनपुटचं कॉन्ट्रीब्युशन किती आहे, that we are calculating means we are calculating the percentage share of each input. So like that, you have to fill this particular table number 2, where I am calculating the percentage share of the different inputs. So whatever the percentage you will get for the 2008 to 9. So in labor, I will write down the percentage. In capital, I will write down the percentage. In the raw material, again, I will write down the percentage. In the last miscellaneous experiment, I will write down the percentage. For calculating the percentage share of each academic year, the formula is same. That is, percentage share of input is equal to total input divided by required input. Total input तर त्या academic year ला कॉन्स्टंटच आहे, फक्त डिवाइडिंग फॅक्टर सगळ्याला काय होणार आहे, चेंज होणार आहे. So this is about the percentage share of the different inputs. Why we have to calculate this particular parameter in the industry? Because from your total input, how much percentage share is given by that particular respective inputs. For that purpose, we have to calculate this particular percentage share as a table number 2. And last, this is very important, which is called as a total and the partial productivity. Total and the partial productivity. So once again, if I will take this particular part or this particular table, so now if I have to calculate total productivity is equal to total output upon total input. So this is the first formula in order to calculate the total productivity of academic year 8 to 9, 9 to 10, 10 to 11 and 11 to 12. And then second formula is called as a partial productivity. Partial productivity is equal to total output upon required or each input. I will write each input. For example, I am giving a, so for 2008 to 9, what is the total output? The last column represents the total output. So what is that value? 42,096.54 divided by, what is the total input? It is given by the second last column, that is 29918.25. So whatever the percentage you will get here, so this will represent the total productivity for the academic year 8 to 9. Similarly, for 9 to 10, the total output is equal to 47674.22 divided by total input 38,497. You will get the another percent. Similarly, for 2010 to 11, for finding the total productivity, total output is given divided by total input. You will get the another percentage in the form of productivity. And for the last academic year, 11 to 12, again in the last column you are having the total output divided by total input. Again you will get the one more percentage related to the 11 to 12. And now we have to check that we have to compare all the percentage in 2008-9. If your percentage is 20, in 2009 your percentage 30, in 2010 to 11 again it is decreases 25, and 11 to 12 it is near about 50%. That means here I can say that in 8 to 9 academic year 8 to 9 percentage is 20%. That means productivity is increases. 9 to 10 from 20 it becomes 30, means productivity is increased. In 10 to 11 productivity is 25. That means from 30% it is decreases up to the 25%, because here input parameters may be increases or decreases. And in the last, again the productivity becomes 50%. That means at the last also productivity is increases. So like that, by using the formula, total productivity is equal to total output upon total input. So in this above particular table, total output is represented by last column, total input is represented by this particular second last column. Only we have to use the formula total output upon total input. So you will get the productivity of academic year 8 to 9, 9 to 10, 10 to 11, and the 11 to 12. So this is about the total productivity calculation. And last one is called as a partial productivity. So what is meant by the partial productivity? So I am calculating the partial productivity for each and every academic year. For example, I am calculating for 2008 to 9. So partial productivity for first one, partial productivity is equal to total output upon each input. What is the first input? Labor. Second, partial productivity for the capital. Again formula, total output upon each input. What is the second input? Capital. Then third one, again total output upon what is the third input? Raw material. And last one, total output upon what is the last? Miscellaneous. So like that I have to calculate partial productivity for academic year 8 to 9, in which I am calculating for the labor, then for capital, then for raw material, and then last for the miscellaneous. Similarly, for the next academic year 2009 to 10, formula is same. Partial productivity is equal to, again, output upon each input. So how many inputs are there? 4 inputs. So formula for the first, partial productivity is equal to output upon labor. Then second, output upon capital. Then third, partial productivity for the raw material, output upon raw material. And fourth, partial productivity is equal to output upon miscellaneous. So like that, I am calculating the partial productivity for 2009 to 10. Similarly, for 2010 to 11, again the formula is same. Partial productivity is equal to output upon each input. At that time, you are using the output of the academic year 10 to 11. I am using the input of that particular academic year 10 to 11, and like that I am calculating the partial productivity of each and every academic year by using their respective output and by using their respective inputs. And if you look at to this particular last table, whatever it is represented, that is table number 2, it is applicable for the percentage share of different inputs. So while filling this particular table number 2, I required only input parameters, total input upon each input. It will be filled by the table number 2. But whatever the last table is there, you can see I have to calculate the labor productivity. I have to calculate the labor productivity, means in order to fill this particular second column, labor productivity means partial productivity. Total output upon labor input, you will get the answer. Then total output upon capital input, you will get the answer. Total output upon material input, you will get the partial productivity. And total output upon miscellaneous input, you will get the miscellaneous productivity. And last column, it represents the total productivity, means academic year 2008 and 9, total output upon total input. Similarly, for 2009 to 10, again the formula for the partial productivity, total output upon labor input, then total output upon capital input, then third, total output upon material input, fourth, total output upon miscellaneous input, and last, total output upon total input, means last column is applicable for the partial productivity. And previous, these 4 columns, whatever I have selected, these 4 columns represents the calculation related to the partial productivity where total output upon each input. So you have to fill all these particular values here, and last column will be applicable, whatever I have selected. Last column is applicable for the total productivity, which is equal to total output upon total input. Therefore, if I have to fill this particular 2 tables, this is your input parameters. So in this particular table, whatever it is filled, for academic year 8 to 9, all the labor inputs are given, addition of total input is given, total output is given. Similarly, for each and every academic year, all inputs are given, total inputs are given, total outputs are given. By using this particular required data, I can calculate the second table, or I can calculate, or I can fill the second table in the form of percentage share of different inputs by using the formula total input upon each input. And third table I can fill by using the formula first, partial productivity is equal to total output upon each input, and total productivity is equal to total output upon total input. And at the end, by comparing all the productivity, I have to check that whether the productivity of that particular steel industry is increases or decreases, because you will get all the answers in the form of percentage. In academic year 2008 to 9, you will check the percentage, and at the last academic year 11 to 12, I will check the percentage from 2008-9 to 2011-12, whether my productivity is increases or not. That I can easily identify by using this particular table number 3. So like that, this is the experiment number 2, where we have to go for the case study on the productivity. So in this particular experiment number 2, the inputs and the outputs of one steel industry is given, and based on that particular inputs and outputs, we have to calculate, or we have to fill this particular table number 2 and table number 3 in the form of calculation of partial productivity, total productivity, and percentage share of the input parameters. So like that, you have to fill this particular tables, and we have to finish this particular experiment. So through this particular experiment, what we have to understood, that is, at the end, in the academic year 2008 to 9, what is the productivity of that particular steel industry? Then in academic year 2009 to 10, what is the productivity? In 10 to 11, what is the productivity? And in the last 11 to 12, what is the productivity? And if I will compare all the productivities from 2008-9 to 10-11, from that particular percentage, I can say that the productivity of that particular steel industry is increases or decreases. If the percentage is increases, then we can say that the productivity is continuously increases. If the in between, if the percentage is decreases, then we can say that due to some parameters or due to some inputs, the percentage is decreases, means the productivity is also goes on decreases. Therefore, the productivity is one of the important tools in order to check the efficiency of that particular organization or the efficiency of that particular industry. So if I have to check that particular efficiency, so like that, the inputs are being given to you as a table number 1, and from that particular inputs, I have to calculate the final results in the form of table number 2 and in the form of table number 3. And from this particular table number 2 and 3 and comparison with each other, I can easily say that at the last, by observing the things, my conclusion is that the productivity of that particular organization or the productivity of that particular industry, if it is increases, then we can write increases. If it is decreases, we can decreases. Because why this particular percentage is required? Furtherly, if your productivity is decreases, at that time we have to go for the modification in that particular industry in order to increase the productivity. So like that, this is the experiment number 2 related to the case study on the productivity. Okay. So these are the 2 experiments. That is, first experiments we have discussed related to the role of the industrial engineer in the industry, and the second experiment is related to the case study on the productivity, in which we have calculated the different types of the productivity for one of the industry. That is, name of the industry is also given here, which is a Steel Authority of India Private Limited. So these are their input parameters, and accordingly, what are the formulas I have represented by using this particular slide, that is total productivity, partial productivity, then at the end, this is the percentage share of the labor input. So by using these particular parameters, we can fill table number 2 and table number 3, and you will get the output. So this is the experiment number 3 related to the total productivity calculation. Okay, so with this, today we will stop here. Again, some another experiments are there that we will take in the next lecture.